We're now going to look at some questions and how we might answer them in an exam. So the first one says, suggest what reactions occur, if any, when chlorine gas is bubbled into a mixture of iron 2 and iron 3. So if we have a look, chlorine gas is only in this electrochemical series here. It's on the left, which means it's an oxidizing agent. It asks us what could happen when it's bubbled into a mixture of iron 2 and iron 3, and we can see we've got iron 2 here, and iron 2 here, and iron 3 here. But if chlorine is an oxidizing agent, it can only react with species on the right-hand side, and so it can only react with Fe2 plus chlorine on the left-hand side. So we're using these two redox reactions. And what we would say is the standard electropotential for the chlorine chloride, remember it's always the left-hand side first, right-hand side second, is greater than, 1.36 is greater than the other equation we've looked at, always left-hand side slash right-hand side. So Cl2 can oxidize Fe3 plus to Fe2 plus, because we go from the first thing oxidizes the last thing, Fe2 plus to Fe3 plus, and is reduced itself to Cl minus. So we can put those equations together. To put those equations together, we are going to have to double this one, and remember it's going backwards. So we've got chlorine plus 2 Fe2 pluses go to 2 chloride ions and 2 Fe3 pluses. And we can work out the standard electrode potential for this reaction. Remember, it'd be right-hand side or the most positive minus the least positive or the most negative, 0.59 volts. Then it's asking us what would happen if this time hydrogen gas is bubbled into our mixture of iron 2 and iron 3. So if we go back up and we find hydrogen gas is on the right-hand side. So hydrogen gas is a reducing agent, and reducing agents need to be more negative. They need to have the most negative number. So we're looking for something on the left-hand side that has a more positive value. So hydrogen's on the right-hand side, and the thing on the right-hand side must have the most negative value. So we're looking for something on the left-hand side with a more positive value. So this time we're using this equation and this equation, and we would say the standard electrode potential of Fe3 plus slash Fe2 plus is greater than the standard electrode potential of hydrogen ions converting to hydrogen. So the two things that could react, when you have a greater than sign, it's always the outside two things that will react. Hydrogen is on the right, so it's a reducing agent, can reduce Fe3 plus to Fe2 plus. It is oxidized, because it's the reducing agent, to H plus. And then we're going to put those two equations together again, remembering to double the Fe one. So we're going to have the first equation, the most positive one going forwards, and we're doubling it. And the more negative one going backwards. And we've got 0.77 minus 0 is 0.77 volts. Our next question gives us another standard electrochemical series. And it says, write the conventional representation for cells 2 and 4. So 2 and 4. So the most positive one is going to go on the right-hand side, and the more negative one is going on the left-hand side. So on the right-hand side, we've got the more positive one going in the direction it's written, the highest oxidation species closest to the salt bridge, then the one that it converts to. Now, these are the same state symbol, so just a comma. But can you connect a crocodile clip to these two aqueous solutions? Well, no, so you use a platinum electrode. On our left-hand side, we've got copper 2 plus and copper. Now, the left-hand side one's going to go backwards. Remembering the highest oxidation state species goes close to the salt bridge, and also that if it was going backwards, copper would turn to copper 2 plus, so this is the correct order. And they've got different state symbols, and so we have a phase boundary. What carries the charge through the wire? Well, wires are made of metal, so it's delocalized electrons, and through the solution, it's free ions. Write an overall equation for what happens, and state the change that must be made in order for this reaction to occur. So the overall reaction that happens is the most positive one goes forward, the more negative one goes backwards. We are going to have to double this top one to make them both have 2 electrons. So we're going to have copper from the backwards reaction reacting with 2 Fe3 plus, going to go to 2 Fe2 plus and a Cu2 plus. And if we check the charges, we can see we've got 6 plus on each side. If we actually want this reaction to happen, we need to remove the voltmeter and replace with something that will allow current to flow. So with a bulb or an ammeter, just remove that high resistance voltmeter that prevents current flowing. And then we have to do the EMF, right-hand side minus left-hand side. So 0.77 minus 0.34, 0.43 volts. Our next question says a species which oxidizes, oxidizing agents are on the left-hand side and need to be most positive. So we need to find the iron 2, iron 3 equation, which is here, and it's 0.77. So we need to find a species on the left-hand side that has a number bigger than 0.77. So this and this are both bigger than 0.77. So we could either have chlorine, or we can have oxygen in acidified conditions. That was O2 with H+. A species which reduces, so on the right-hand side and more negative, and it's got to do the 0.77, but not the 0.34. So it's got to be less than 0.77, but more than 0.34, and on the right-hand side. So we've got the only number between 0.77 and 0.34 is 0.54, and we have to take the thing from the right-hand side. So iodide ions. Our next question shows us 3 redox systems and says, write equations for reactions that are feasible. So remember, they're feasible if one species has a more positive value than the other. So we just start at the top and start making combinations. The electropotential for copper plus copper is greater than that for chromium 3 plus chromium, which means copper plus will react with chromium and oxidize it. To combine those, we would need to times this one by 3. So we're going to go 3 Cu plus a chromium goes to chromium 3 plus 3 Cu. That'll be our first example. Yeah, Cu plus oxidizes chromium to chromium 3 plus. Our next combination, well, that 0.52 is also greater than 0.17. And to combine those two, we now need to times by 2. Cu plus is able to oxidize SN2 plus to SN4 plus. So we're going 2 Cu plus SN2 plus, so doubling the copper equation this time, goes to 2 Cu and SN4 plus. That's our second possibility. And our last possibility is if we were to combine these two, the electrode potential for the tin 4 plus, tin 2 plus reaction is greater than that for the chromium 3 plus chromium. Do that one again. So first thing on the left, SN4 plus oxidizes the last thing, chromium to chromium 3 plus. To combine these two, this needs to be doubled and this needs to be times by 3, so they both have 6 electrons. Remembering the more positive one gets to go the way it's written and the negative one backwards. So 3SN4 plus 2 chromiums, it's giving us 12 pluses on the right, at the left, sorry, is going to make 2 chromium 3 pluses, that's 6 pluses, and 3 tin 2 pluses, that's another 6 pluses. So the charges balance. Right, our next question says a piece of tin metal, which is Sn, is added to an excess of acidified potassium dichromate 6, which is this. Use the data in the table to predict the tin species present at the end. Okay, so I'm going to do the explanation first because it'll help us come up with the answer. The standard electrode potential for dichromate chromium 3 is greater than tin 2 plus / tin. So what that means is that tin is going to get oxidized to tin 2 plus by dichromate, but what you can see is that as well as being more positive than that, it's also more positive than the other one. So dichromate can oxidize tin to tin 2 plus, but it can also oxidize tin 2 plus to tin 4 plus. So dichromate oxidizes, it's a very powerful oxidizing agent, tin all the way to tin 4 plus. So the tin species present at the end is 4 plus, and the half equation for the formation from tin would be tin goes to tin 4 plus, and if I just balance that half equation, I can see I need 4 electrons.